Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. Before introducing today's guest, let me tell you a little bit about what Data Unchained covers. In our conversations, we talk about how decentralized data is increasingly being generated in all kinds of really interesting places, whether it's the obvious places like sensors and phones and distributed clouds, but even off into space and really anywhere data is being generated. Now that AI has come about, there's a lot of value to it. And in Data Unchained, right now, our focus is really on how do you figure out which data you want to use with your AI, get it there, and get some business value out of it, especially without putting any added business risk in. So today's guest is Jack Hogan. He's the VP of Advanced Growth Technologies at SHI. He's an expert in what's happening with the AI space, but as well as how technology has been evolving over the past couple of decades to get us here. Jack, welcome to the show.
Hey, thanks, Molly. It's great to be here.
So before we go into the meat of the technology, tell us a little bit about yourself, please.
Sure. Listen, I have an interesting background, I think, for the topic here. I have been at SHI now for a little less than 2 years. I was actually brought in to specifically build SHI's data center hybrid cloud and AI practice. That has really led into a lot of the things we built out around SHI's AI and Cyber Labs and the team that I now represent, over 200 resources strong. But the prior 7 years to that, I was the VP of Technology Strategy at what is now Everpure, but Pure Storage. So in the data storage space, I've been in the really kind of the data world, but in the storage space, looking at kind of the how data can be pipelined fast and kind of grow out. But, from, that representation history, I actually was prior to that, a 20-year prior to that, a customer side co-founder and CTO of LifeScript, where we dealt with massive data scale problems. We were a web scale company dealing in billions of transactions a month, hundreds of millions of page views, tens of millions of transactions from registrations. And so I was dealing with really some of these big data problems for a long time. But actually my history with AI goes all the way back to, right out of college, 1995. I actually used, at the time, early stage machine learning technologies, and I wrote a neural network program to predict the movement of the Swiss franc future. So I feel like my world has come back to kind of full circle now that AI and especially generative AI and kind of now where we're taking the limits of data applied to AI. I always say data is the new oil. I've been saying that for the last 12 years. I think we're now seeing that importance of being able to refine that data and use that in really powerful ways. So it's great to be here working with Hammerspace and with you.
So how did your models on the Swiss franc prove out? Were they fairly accurate?
They were fairly accurate. Actually, the house that I'm in now actually was paid for through the proceeds of some of those early stage models. So I was pretty successful with that. And it's interesting because those models were machine bound at the time. So I understood the physics of how data pipelines through the chip and how that turns into kind of predictive models. And so it's kind of, quite, the timing here is very, very, very good stuff for us to be talking about the topic we're talking about here.
Awesome. So tell us about SHI. I know you have a personal and specific focus in AI right now, but SHI has done a lot of things in tech for a while now. Give us a little bit about the company background.
Sure. Yeah. SHI, it's a great story. SHI was founded almost 37 years ago, when Ty Lee bought what was at the time a software license reseller focused in IBM licensing. SHI has now become really one of the largest software resale companies in the world. We've got some very, very large partners that we work with, like Microsoft and ServiceNow. IBM still kind of in there. But our lineage has been in software. But we have now a huge focus in full stack. And so that was really a big part of my role, is to come in and really take SHI's breadth. We do $16 billion a year in revenue. So we have 17,000 customers, and so we're actively helping customers with their problems out there. And we now are really focused on full stack solutions, recognizing that you have to look at the physics, like I talked about earlier, of how the systems are built, where they're deployed, how they're even powered, and take that all the way up into how the data pipelines into outcomes. And, so I think it's a testament from Ty Lee, our CEO, who is still very active in the company, that she really believes that there is a huge opportunity for the world to be helped by SHI's extreme help capabilities that we bring in. We try to be ridiculously helpful. That was a former tagline, but it's one that I think that is still kind of at the core and ethos of what we do when we talk to customers and what we're trying to achieve and helping them really, address this new world of AI and the big data problems that we have to unlock to really unlock the value of AI.
So, Jack, let's just delve a little deeper into what SHI is really offering. Certainly, you have some foundation in being a reseller and do that, but I know you've evolved far beyond that and have some really massive investments in a larger scope of the business. Can you tell us a little bit more about that?
Yeah, well, first of all, thanks for the question on that one, because I think it is important to separate out what SHI has kind of historically been known as is really just a reseller. We take orders, we sell a lot of software. But when I came over and started to kind of build this practice, we recognized this high failure rate that's happening. And it was really important for us to really take a completely different approach when it comes to like full stack AI solutioning. And that was that we actually had to be very consultative throughout the entire process. This is where we really kind of invested heavily into this imagine, experiment, and adopt framework, where we kind of took ourselves from being just a seller to now actually a consultant, to help customers guide them through the process. By the way, it's a recursive process too, that, as we get them through success of one project, we can bring them back to another. But, in that imagine phase, we needed a location to be able to bring customers in and show them what was possible with AI solutions. But then we needed to get to a place where we can actually experiment and prototype this for customers. And that was a very substantial investment. At the time, this was a year ago, we actually did the ribbon cutting. I think, we were the first to actually have a lab specifically dedicated to this type of work. We were acknowledged by NVIDIA for that being an important piece that they hadn't seen from anyone else. While there was other labs out there and there was other kind of demonstration environments, this was actually a place where we were building things out in that experimentation phase. And that experimentation phase is the most important part. That prototype is really critical. So millions of dollars, tens of millions of dollars actually, and continued tens of millions of dollars of investment into that environment is really the commitment that Ty had to help customers in that phase, so that we can then get them to proper adoption and get them through that final phase. So, our ability to kind of convert from a reseller into a trusted advisor, a consultant along the way, introducing this really thought through imagine, experiment, and adopt framework. Actually, NVIDIA just recognized this last week at GTC with an NPN Partner of the Year award for service provider. We are the rising star, which to me indicates that they're seeing that we are visionary in this. We are actually taking a completely different approach because we recognize that NVIDIA has done very well in selling to the hyperscalers, but there is a opportunity in this enterprise space that has yet to be fully uncorked. And we are leading the way there and kind of being recognized for it.
That's really awesome. That's a huge win. Congratulations. I'm sure you had a massive presence. You and I were both at the NVIDIA GTC conference earlier this month. Tell us a little bit about maybe some of your insights from the show. What were your big takeaways? There was a lot going on, a lot of people, a lot of sunshine. But kind of on the announcements and the technology, what caught your eye?
Yeah, well, first of all, what caught my eye, just the scale. I mean, what GTC has become, the scale of it. I mean, it was nearly double the size of last year. And I think last year was kind of overfitting its space. But what to me was really interesting, I think there was a few things that I think were front and center, very relevant to our conversation. And first of all is that, Jensen introduced what he calls the 5-layer cake, starting down kind of at the bottom, the energy layer, then up to the infrastructure layer, into the chips, into the models, and into the applications. And when I talk about full stack AI, that's what I mean. That is all the way from top to bottom. And so I think it was a good, refreshing kind of testament to how I and SHI are really approaching solving customers' problems, that you have to address the full stack. I joke that kind of in that infrastructure layer, where the data really comes into play, it's not just one layer of a cake. It's actually a whole bunch of, what I'll say, kind of crate cake, probably 100 layers in there, because there's so much information about data that it's a problem to deal with if you don't have the right solutions, you don't have the right partners. And so that was kind of first thing that I thought was very, very real. I think the other part is now companies are starting to recognize that agentic processes and the utilization of properly structured and properly governed and properly controlled and even properly discovered data is the fuel that's driving this token use. I mean, we're talking 100,000 increase in the amount of tokens, or that's massive scale. It's not just a 10x problem; it's a 100,000x problem when we start to think about how to solve these things and how now agentic processes are really kind of taking the forefront. So again, going back to the data, and if agents and systems are going to autonomously operate, they have to have a proper data pipeline.
Absolutely. And you mentioned, as we were kicking off, Nemo Claude. That was another kind of cool, maybe not quite the focus of this conversation, but what about Nemo Claude did you really get excited about?
Yeah, I think what Nemo Claude is really kind of opening up, and I'll kind of take it even higher level, Open Claude, and even some of the things we're seeing from the frontier model companies, that now with this agentic process, the concept of the operating system itself is completely being transformed. We're no longer talking about desktops and browser windows. We're actually talking about workflows and systems that operate autonomously, the new operating system of the business. And when you look at Nemo Claude, you look at OpenShell, the approach that NVIDIA is taking in this open ecosystem, open weight, open model approach, it's now becomes a huge opportunity for companies to take advantage of agentic processes without being bound to any specific, whether it's a model or whether it's an application plus a model. So I think that is probably the most impactful thing for customers to come away from, or, that I came away from that saying, wow, it's a new thing, and people need to understand what the implications are for their business, how they structure and manage their security and context around their data, how they allow agents to use that data. So, I mean, to me, I'm a data-centric guy, so it keeps coming back to that. But I think that the fact that we're now talking about a completely new operating system, or really an operating model, I think companies have to really realize that it's a fundamental step change in how this ecosystem around NVIDIA is unlocking just completely new potentials. And, it's kind of part of how SHI goes to market, is allowing, what is the possibility of that potential, the imagination piece. We talk about imagine, experimenting, adopting, that's our framework. We operate like that. When you start to introduce something like Nemo Claude, the possibilities become endless, and what it can do and how powerful it is.
It's kind of interesting. I've seen some of these memes floating around about how developer languages have changed, going from really old models to C to Python to Rust, and now it's just English, natural language. And then you think about the operating system evolving. Like, this is a whole new world of how we interact with computers, how we give them cues, give them responses, and then how they're doing the work within the enterprise. And I think, as we delve into this conversation around the data and the data layer, that's kind of a foundational piece of all this, that all this cool stuff is cool. But if you don't have data and the right data to fuel that pipeline, it's kind of all for naught. So maybe you could talk a little bit about the concept of an AI data platform. And maybe, that's kind of sounds like a generic term, but in the NVIDIA world, that means something really specific. If you could talk a little bit about that, I think that'd be a great way to get started.
Yeah, well, and I kind of, in my opening, I kind of alluded to it, that, the physics of these AI and ML systems come together are really important. When I, wrote my program back, 30 years ago, or a little more than that now, it was apparent to me that when you went from a 33 megahertz chip at the time to a 66 megahertz chip, just by unlocking that doubling of throughput, you actually literally doubled the performance of the models. That plays at the AIDP layer. When NVIDIA is now introducing a layer that is truly the pipeline into using all the parallelism optimized for the NVIDIA stack, leveraging the AIDP framework, it really cannot be understated how impactful it is to have an engineered solution that takes full advantage of those physics, the chip physics, the network physics, and the data flow physics to actually address this layer called AIDP. And I agree, with one thing, with a big thing you said there is it sounds like a generic term. It's an AI data plane or AI data platform. It's actually an embedded component of the workflow processes of how these how AI gets processed. And so it's really critical understanding when NVIDIA came out with AIDP and, getting companies like Hammerspace has addressed that, firsthand, and they're now part of a really unique ecosystem. And you guys, look at this as a data problem. A lot of other companies are looking at this as a storage problem. It is not a storage problem. It's a data problem. And what NVIDIA is unlocking with AIDP is really that flowing of the data, regardless of kind of where it's being served.
So you've had a chance, going back to where you were, working on building models even 30 years ago, but thinking more recently with your work with SHI, even at Pure, AI projects got started and grew fast and furious with some of the big model builders and the foundation model builders. And then there's a lot of conversation about, is enterprise really gain value from AI? Some of their initial pilots have stalled out pretty quickly or not really brought fruition to having real value to the company. Can you share why you think that has been happening?
Yeah, I think there's a number of reasons why I think that's happening. First of all, if you take a look at the foundational models that the world kind of became exposed to in November of 22, ChatGPT, released their 3.0 model. That was kind of a seminal moment to allow people to understand, wow, like these things have been trained so accurately on the world's data. It has the world's information. And what I mean by that is it's whatever it publicly can consume and whatever repositories, and then the training that happened. And so when you have that kind of foundational model, when companies just look at using that and saying, hey, I'm going to do a simple process, I'm just going to add RAG to that, meaning I'm going to add my own company's data and context to that. Now I'm going to get a better output from a chatbot. Well, a chatbot's really not what you're going to see. I mean, maybe there's productivity gains in certain areas, but what companies aren't realizing, and we kind of have a 4-pillar approach when we work with companies, is we do their AI readiness assessments. We start with, first of all, is the company culturally ready? A lot of the projects, I think the latest stat that I think I hear a lot of people quoting is the MIT study that came out last year, I think it was end of last summer. Around 95% of generative AI projects are failing, and we see it in companies that are coming to us with failed projects or companies that haven't gotten started. But mostly the ones that had failed projects is because culturally their company wasn't ready. That's kind of pillar one. So there's a foundational layer of understanding, like, what should I expect out of AI? What can it do for me in my business? And what are my business goals? Like that's an important part of that first pillar. But the second pillar is data. Is my data the right data in the right format, with the right governance, with the right security, with the right compliance? In some cases, in regulated industries, you have to have very secure controls over how that data is being used and processed. So data is a really key pillar. And then the third is getting into the infrastructure. How are you setting up that infrastructure? AIDP is super relevant in that, like, how is your data pipelining into that infrastructure? And then finally, it wraps back all around that is the security. So those 4 pillars for us is really an important part of understanding, well, why did people fail? Well, they probably didn't assess all 4 of those pillars. They probably had unrealistic or maybe even undefined business outcome goals. They just said, hey, I'm going to take ChatGPT and make it an internal application, rather than saying, how do I apply the AI technologies to business problems that I can culturally adopt to with the right data and get the right infrastructure and ultimately go in and have success. So we've seen plenty of companies who went out and just bought a bunch of GPUs and said, oh, well, this doesn't work because we have got nothing to feed it. Once again, they didn't go back through that assessment process to say, what are we trying to achieve as the business goal up front? How are we going to bring the right data together? How is that architected in the infrastructure? So I think we can radically, and we see this in the customers that we work with, radically reduce that failure rate or improve their success rates when you go through that proper process. And then for us, it starts with imagining hey, what are you trying to achieve? What's even possible? The scale of SHI gives us the ability to, show companies what is out there. What are solutions off the shelf? What are solutions that can be co-engineered or brought into an application? And then go through use case identification and then get to that readiness assessment. Those are all prerequisites to make sure you don't fail. Then it's about making sure, rather than jumping straight into the deep end of the pool, you're actually validating prototypes and building the actual the outcome and the proof of value up front in a way that can then be structured and scaled. And then that moves into the final phase, which is adoption. And a lot of the projects we've also seen from a failure point of view is that companies aren't really ready to take on massive scale, AI clusters, or even managing Kubernetes clusters that have to operate in unique and different ways. So that adoption phase, that final, like, I now have the system up and running. So we've seen failures from companies across all that. They kind of add up to that. Why have companies been a little disillusioned by the potential value of AI solutioning? We believe they're not approaching it appropriately. And this is why, really we at SHI have introduced things like our AI and Cyber Lab and our approach to our customers that Imagine, Experiment, and Adopt framework.
So as we break that down, we actually had some of your colleagues from ServiceNow on just an episode or two ago, and they brought up the same topic, kind of around culture and company readiness, and how at ServiceNow they help kind of workshop that. What is your approach? That's kind of like a people and policy versus a technology topic. How do you tackle that before you jump into the which platform, which networks, and all of the other things?
Yeah, well, I think we're addressing it kind of two ways. One, when we have a specific engagement where we're being asked to really solution something for a customer, we call it kind of the AI buying triangle. If you don't have the right stakeholders in the room, you've got a major problem, and that's kind of part of that business readiness. And in that, AI projects right now are in a lot of cases coming out of the C-suite. It's a line of business leader. They're the ones that control the budget, and they're either, pushing that down to IT, who's another part of that triangle, and saying, go build this, buy this, do whatever you need to do. And they're missing the most important pillar, which is who are the people that are going to use this? Who are either the citizen developers, the data scientists? So bringing together that kind of triangle is really important. So when we do our use case workshops, and we have to bring all those representatives into the room. That's an important part. And then when we uncover and identify companies that really don't even know where to even consider getting started, they even haven't identified their cultural readiness. We have partnerships and have worked with some of the leading research universities. We have a solution from a course module. It's a 20 course module that you can go through, and it will help your company really understand the foundation of AI and what could be applied there. And it's actually New Jersey Institute of Technology, and one of the leading research universities around AI development, have realized that you have to have the foundational components. And so that's a training course that we can provide to our customers. And so we try and solve it both ways: fix the cultural problem and then address the buying and the decisioning problem. We do that together, and it helps accelerate our customer success.
You've used the term a few times, build and buy. What are customers doing right now? Are they building out their AI stack? Are they looking for something more integrated and packaged? Where are different types of companies landing there right now?
We're seeing the ones that are successful. In a lot of cases, they're really starting with a cloud first approach from a development point of view, and then a private cloud deployment from an operational point of view. And it's important to realize that a lot of the hyperscalers have their own proprietary kind of AI tools that do become monoliths and really can kind of trap your AI workloads. But when you think about trying to then scale them, so it's a great place though to do development and figure it out. Like what are you trying to achieve? Can you use some of those tools and do some modeling and some proof of concepts? But when you need to move into a production environment, you really have to think about the economics behind it. You have to think about what type of token use you're going to see. What happens if all of a sudden you have kind of unchained environments, and then also there's a security component that drive customers. So we're seeing this model of develop your solutioning in clouds or on even private enclaves like the DGX Spark or the GB10 devices, or another place that we're now really starting to see a lot of companies say, hey, those cloud GPUs are expensive. Why don't I just get my developers these supercomputers on a desktop that can operate just like they will when they go to that production environment, but give them that sandbox environment and then allow them to scale that into a production environment that is much more controlled, that's designed and engineered specifically for what their application is intended for. So that's the trend we're starting to see. I've heard a lot of people talk about this concept of repatriation of workloads. It's actually the proper balancing of workloads. It's using the environments what they're best intended for. Once what your agentic process or your model for your AI or however you're deploying it is going to be used, when you get to that inferencing phase, it actually starts to become much more economical to run it in that private environment on infrastructure that you can control or even burst into when you need. So, there's this wonderful landing zone in between kind of the hyperscaler clouds and, the on-premises data centers, and that's the neo clouds. And so, we guide customers to ensure that they have a properly thought through scale out framework once they move from the testing into production.
Hammerspace and SHI have been partnering now for quite some time on building out a reference architecture around an AI data platform. And that's kind of taking another layer down of getting your data AI ready, which I kind of love that term, that just because you have data doesn't necessarily mean it's ready for AI. Can you talk through not just what are the components in an AI data platform, but what purpose does it solve in this kind of overall scheme of you have models maybe in a few different spots, you're processing data in one, you have GPUs in other spots. Kind of what does the AI data platform do?
Well, I'll kind of take two parts of that. The AI data platform is kind of that optimized input layer, but so that's one layer, and that's an important layer, right? You're taking advantage of the most optimized throughput of where your data is being used. But there's a whole layer below that, which is the discovery layer and really that universal namespace. I think one of the incredible things that Hammerspace has always had that ability is that universal namespace to be able to really kind of assimilate all data from no matter what source, whether it's in a cloud hosted service, whether it's in a cloud instance, or whether it's in an on-premises storage array, or even in an archival array or data storage system. Like being able to have that kind of visibility across where all your data is, even your systems of record, like that ability to have MCP systems come in and now kind of put even greater context, even security controls over some of the data itself. So when you kind of take the AIDP layer, you then take a discovery layer, things like what Sakuvi does, being able to even just discover, classify, control that data, and then a universal namespace that can pull all of your company's data. Now, all of a sudden, you've given your developers, you've given your users really a pipeline, streamlined pipeline of all the information they may possibly want to put into a data flow. Adding context. I think it's interesting that context is a human communication concept. When we talk about I need a little more context about what you're asking me about. Well, data has the same problem. If it doesn't have the context of what it is intended to be used for, or why it exists, or how it applies to another set of data, that context is really important. And you hear when you talk about kind of the models themselves opening up their context windows. Well, the AIDP and the AI data layer is really an important part of having that available data, that available data that needs to be used for high throughput and high revenue outcome.
I was at a talk a few weeks ago that Jacob Lieberman, one of the leaders from over at NVIDIA, was talking at, and he likened this to, it's one thing for humans to manually put together a curated set of data for a POC. Okay, let's put it together, let's organize, and now we'll test our environment with this. But then when you think about running this in an enterprise where data is changing, being deleted, created, moved constantly, and lots of different humans and lots of different applications involved with that, you can imagine the value of this context being created automatically by machines, not by human data scientists, right? They're curating a data set. And that's a big part of putting enterprise AI into production, or a sovereign AI environment where you want to be sure your data is being kept safe and you're also constantly finding out what's new and using it properly. And I think that's kind of what you're saying that you're addressing here is the automation and reaching out across the enterprise and then having the context and using just the right data at the right time.
It's interesting. I think people don't have really, the relative concepts of how much data you have to be able to have a human manage. As you were talking there, it reminded me of a story I was asked during a presentation about 10 years ago, may even been a little further back than that, of boy, could you ever imagine getting to more than a need of 100 terabytes in a specific storage frame? And I had to kind of pause and I thought about it. I said, I actually remember when a 1.2 megabyte floppy drive, it was a 700 something kilowatt or kilobit drive that if you pop the corner off the side of it, now you can turn it to 1.5. I could manage 1.5 or 1.2 megabytes of data as a human being. I could classify probably each line of data that was there. But when you now say you move from megs to gigs to terabytes to petabytes, and now we're talking companies we see have some exabyte scale. Like those are 1,000 times each. So now you're talking about millions of times more data that that's stored somewhere that somebody needs to classify. It's no longer a human problem. It's a machine problem. You have to have automated classifications. You have to have the ability to pipeline that data in different ways, because it's not that floppy disk you can just stick in and tag each line. You have to have that ability to manage, discover, classify your data at a scale that is, and it's only increasing, right? It was just 10 years ago I told that story. Now we're at exabyte scale. We were talking about 100 terabyte scale at that point.
Yeah, absolutely. And in this whole process, what are you seeing that security teams want to see? Assuming this has been all automated and classified, what is the report out? Is it auditing? Is it, what does that look like that makes them say, okay, I feel comfortable with this whole pipeline that's been put together?
There's a number of different layers there. I think depending on the company and the industry, there are certain compliance issues you have to abide by in certain industries, just simple things like GDPR, HIPAA, all the compliancy things that need to happen, even industries that can only share certain amounts of data. So there's part of the security component is just having the context around the, what is actually data we can use, what has to be obfuscated, what has to be essentially, controlled out. Then below that is then the governance. Who, or in this case, which machines can access which data sets? That becomes really important of being able to kind of go down that click down to say, okay, now you've got machines that are making autonomous decisions with data sets that they may not or should not have access to. So you have to have really tight, governance around what systems and people are accessing that data. And then, beyond that is which versions of the data. That's an important place to say, a company report from 10 years ago that maybe you use as training data may not have as much restrictions as the most recent 10Q, or the draft of the 10Q that you're actually, you're writing. And so the security team wants to see, whatever data is flowing into that to have that multi-layer approach. Now, the other side of that is, security also wants to see how are the individuals, the humans, employing the agents against those, and are they deviating out of company policy? The greatest data leakage and security vulnerability that exists right now is the Control C into a browser window. You have information that can easily escape your corporate domains just by simply copying it from a file and putting it into a prompt. And now all of a sudden you've released intellectual property that is not controlled or governed. And so, my advice to companies that are experiencing that is, first of all, understand the leakage problem. We have tools and partners we can bring in to actually identify that. But then that goes back to why you need to have a data security strategy around AI, and you need to be doing this in a private environment, where you're actually providing all the tools and the mechanisms to the people that interact with it. And when you multiply that times the agents that interact with it, it becomes an even bigger vulnerability. So, those are the things that are super important on the security side around data is, know your perimeter, but also know your compliance, your governance, and ultimately, your data set, lineage.
This market is moving so fast, and the opportunities, the technology is evolving so quickly that some things that just were a huge deal even a year ago we haven't talked about yet. I want to touch on those oldies and goodies. So keeping GPUs fed. That's all we were talking about a year ago, is how do you keep those expensive GPUs fed? Is that still an issue, or is this data readiness kind of where people are now? I mean, GPUs are expensive. I imagine it's still in people's minds.
Well, yeah, absolutely. When you get we're starting to measure things in kind of the token scale, or apply that to the energy scale that's kind of feeding this stuff. When you look at, I think Jensen mentioned it, a gigawatt scale data center that is now the foundational unit for some of these AI factories that are being built out. When that's a $40 billion build, like, your GPUs better be fed 100% of the time. Like that is a tough payback on that. And so, we certainly work with companies to ensure the proper GPU utilization, and we often find that the biggest problem is they're being starved at the data input layer, which is why, by the way, data IDP is super important, but also what data is feeding into that. So it's pipelining, and you need to be able to be putting those GPUs to 70, 80, 90% utilization all the time. And in order to do that, you have to have the right pipelines on the data side.
Which kind of ties back to what you were saying earlier on the scale of what you could manually manage on your floppy drive versus what can you manually manage when you're talking about keeping these GPUs fed. It takes a lot of data and a lot of preparation to feed a GPU too. And so this automation of getting big data sets put together and curated quickly for GPUs is another, part of the economics, certainly, not just time to results, but the economics of making this all viable. And I want to bring up power too. You mentioned these massive data centers that are being built out and the power that is available to them, but is power availability limiting the enterprises right now? I mean, some of the big hyperscalers have interesting approaches, building their own nuclear power plants, but for, everyone else, how is this affecting them?
Yeah, it is affecting them. There's kind of two ways we're addressing this. One is identifying actually what data needs to be processed where and what are the right chipsets, because not all of them require these super high scale systems. I mentioned earlier the GB10 and the DGX Spark and those systems like that. That system itself can run on a desktop. It uses kind of nominal 110 power, can operate like a supercomputer. It's actually as powerful, if not more powerful, than the original A1 that was developed by NVIDIA. Like, you don't need massive scale power for the application of just developing. But when you need consumption at scale, when you're now talking AI factories, you absolutely have to evaluate, are you ready to power it, just generally get the amount of power that needs to run these chips, but then they run at such a high energy consumption that they're putting off a tremendous amount of heat. Is it being cooled correctly? So there's systems in between those that can be air cooled. There are systems that are just as sufficient from a utilization of the energy that are air cooled. But as we're seeing more and more of these AI factories enter the scale, even for enterprise. And I'd say it's not just the hyperscalers that we're seeing buy these massive scale NVL72 systems that now need consultation and help. And so, we have an entire power and cooling practice where we're bringing in consultation around the cooling components. And now we're even bringing in things like behind the grid power generation at the distributed edge, meaning kind of small scale, 5 megawatt, 5 to 25 megawatts. There are solutions that are kind of helping solve the current problem is actually the grid. Getting enterprises that power from the grid is that final mile is, in a lot of cases, a 3 to 5 to even 7 year problem that enterprises have to kind of come around to address. that's why we're trying to bring into market some of these alternative power solutions. And if you take this all the way up to what's going on now in Washington and in different state levels, you're not talking about there being mandates that you have to bring your own power at a certain scale. Well, I'd say the enterprise should think about that as well, because it is a challenge to secure the right amount of power and energy to run these chips. And the good news is when you do approach it appropriately and you do think about alternative ways to do it, you can actually dramatically reduce your overall operating expenses for these. Of course, there's great landing zones in the middle. There are some, there's co-location providers that can do a lot of this, but even they are starting to become saturated with customers are, finding the space, contiguous space, and the power, and then the ability to bring in liquid cooling. They're adding time. So we think that having a whole data and power practice at SHI is really important for our ability to help speed up the acceleration and adoption in the enterprise in particular.
Organizations definitely have to think about how to use things that are sparsely available right now. It's interesting. I just got thinking about memory's a shortage, SSDs are a shortage, power is a shortage. There's a lot of shortages to deal with right now, and thinking carefully through what you're deploying, how you're deploying it, where you're deploying it is becoming critical. I mean, it's a mandate because there's just not enough of the things to go by at this point. And as you're advising customers as they're moving forward with these dynamics and shortages and security issues and whatnot, I think this is a place where consultative help is just mandatory for most organizations. And I know SHI does a ton of that. But, as we wrap things up, what other kind of key takeaways would you leave leaders with of where should they be focusing right now to be ready for this next wave of AI? Are there just a few things you could synthesize down as key things to watch?
Yeah, I'd say, first of all, if you haven't started an AI and started actually implementing AI for proper business utilization and the improvement of your internal processes, and then the ability to go kind of identify new market opportunities, get started now. We are transforming so rapidly in this industry that companies that didn't exist 2 years ago are now worth billions of dollars, and companies that existed 2 years ago that are worth billions of dollars are going out of business now. And that's all because of what's happening with this wave. We're completely changing the way that business is done as a result of AI. So get started first. Second of all, don't go it alone. Do not expect that you can actually do this with a science project and a couple smart folks. Bring in experts. Bring in the folks like SHI. Bring in the folks like Hammerspace. Bring in the folks like NVIDIA that actually have been doing this at scale, because we can help rapidly accelerate success. Not just get you going. We can actually accelerate the success. So I think that's another approach. And then probably the most important part of that whole process is have an actual business outcome you're trying to achieve. Like, be able to quantify what that is. I mean, it could just be a productivity gain. It could be an improvement in just your creative process. It could be an improvement in your customer experience. It could be an improvement in research. That's how wide ranging it is. But if you have that, it becomes substantially more. It's substantially easier to get to a quantifiable measurement, to ensure that you're not being left behind, and to ensure that you've got the right systems and they're optimized for, fit for purpose, and that you're actually getting on that curve and accelerating fast.
Pulling in the experts is great recommendation. There's a massive amount of data out there. I can't even imagine parsing through everything that happened at GTC and the information that's available there. And a lot of it is available online, but if folks want to get in touch with SHI, talk about what kind of engagements are viable, what's the best way to reach out to your company?
Well, I'd say there's a super simple, easy way for me. It's ai@shi.com. As an email address, you can email. My team is actually the one manning that to ultimately ensure that we can engage and help customers. Of course, we've got a tremendous amount of information in our AI solutioning section of shi.com. You can read about kind of how we approach this imagine, experiment, and adopt process. You can read about what we're doing in our AI and Cyber Lab. You can look at different customer win stories and use cases that we've been able to rapidly adopt, kind of things that weren't even conceived of before we started engaging with a customer. So I would say, just start there.
Jack, thank you so much for joining the show today. It's been great working with you, both our companies as well as having you on the show. And, maybe we'll have you back here in another 6 or 12 months because it'll probably be a completely different conversation.
I'm sure it will be. And it's great to be here. Thanks, Molly, for the opportunity to have a conversation with you.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.